let's make our model of exponential growth more realistic. As I said before, models are abstractions. In fact, many models are toys. What are toys? They're simple objects that we can manipulate, that we can play with in order to represent something that exists in the real world that we care about. For example, here's a toy. It's a zebra. It's a zebra car with some wheels on it. And this is a simplification of a zebra, or perhaps a simplification of a car. Neither a zebra nor a car looks like this, but it is recognizable as a zebra, and it functions as like a car in that it's got wheels. And we can play with it. We can do things with it that are representative of one or the other of those things. However, it's still, it has its limitations. We get to a certain point where it won't tell us any more information that's realistic information about a car or a zebra. That's not to diminish how much fun it is, especially with a 2-year-old, but I digress. So let's add some realism. Let's add some realism to this to make it more representative of how natural systems work. Then the first bit of complexity that we can add to this model is what's going on within the reproduction rate. Now, reproduction is a function of 2 parameters. The first is we have to have births. We have to have births of individuals, and we can also add in mortality in this case. So we can have death. So we've got birth minus death, make this per capita, and then multiply this by the population size, and we've got something more realistic. In fact, if we allow birth and death rates to change in time and make these functions, then we can end up with something that is maybe even more representative of mortality, of reality, something that has that will not be unconstrained growth. That's the big problem with exponential growth, is that it's not very realistic. It is unconstrained. As I mentioned, this behavior of the model going up into infinity is a real problem. It is, infinity, like I said, is a bad number. It does not behave well. It does not play well with other numbers. And we quickly get to a point where we're constrained and we're into a place that is unrealistic. No population, whether it's trees or animals, grows into infinity. And that's good, because otherwise the world would be covered with it, and so would the entire universe. And that would be some sort of existential problem.